Okay, this is 39, number 2, and it says, Kim measured the angle between the base of the tree. Oh, you didn't put it in the folder?
Yeah.
The folder's right there. And then you can put the folder inside the bag, or just leave the folder there and I'll get it later.
Did you get it?
Okay.
Yes.
So, she measured the angle between the base of the tree and the top of the tree and received a reading of 1.2. She was 1,500 feet away from the tree.
This problem, I don't like it.
This is the tree. Here, I'll make it like a tree. Okay, there's the tree. It's going to be a triangle tree. She is, so where is she? She's 1,500 feet away from the base of the tree. How high was the tree? So this is that one I was talking to you about. This is 1.2. I know it doesn't look like 1.2 degrees. You could use inverse, or you could use tangent on this if you want. You could just say tangent is opposite over adjacent. So I'm going to do it this way, and then I'm going to show you the way the book wanted you to do it. Tangent of 1.2 equals opposite over adjacent. Right? That should. Do you guys recognize that? Remember when we took the kilometers or clinometers outside? And okay, so you're gonna you can just cross multiply. X times 1 is x. 1,500 times that is 1,500. Tangent 1.2, and then bust out the calculator. Here it is. Here's my Cadillac calculator right here, the best one ever. 1,500 tangent. Tangent, you can't see that very well. So I got 31.42 degrees-ish. 31.42. Okay, so this is how I would do the problem, because I believe that there's a right angle here, and that enables me to use my SOHCAHTOA. But your book just taught you something new. Remember they taught you that arc length? Does that look like an arc length? Not really. It's not very round, is it? Arc length equals radius times radians. So for some reason your book wants you to do it this way. So the arc length, which is actually how tall the tree is the radius, which is 1,500, times the radians. Now to get that into radian measures, I just go like this. 1.2 degrees over 1. Does anyone remember the unit multiplier to convert the radians into the pi over 2? There's pi over 2 radians in a circle. So pi over 180 would work, right? Pi over, because, well, why is that true? Because 360 degrees equals 2 pi. We said when we go around the circle, it's 360 degrees is 2 pi. So that means if I divide both sides by 2, that means pi equals 180. So that means I can write it as, it's like what we call a giant 1. It's like multiplying by 1. Okay, now these two will cancel out because I can go find out how many 1.2s are in 180. There's 100. It turns out that 1.2 goes into itself once, and it goes into 180 150 degrees. Okay, so that's pi over 150. And then I can go, so now I can go, that's pi over 150. Hey, is this working? Yeah, this will probably work. And then I can do fraction math right here. Right, because 150 goes into 1,500 how many times? 10. So that's a 1 and that's a 10, and then I got 10 times pi. Well, what's 10 times pi? Isn't it really close to 3.42? Oh, wait, not really. It'd be 3.14, it'd be 31.4. Do you think I messed that up? Was that 31.4? I think I wrote the wrong thing down. Now I can't.
31.42.
Yeah. 1,500 tangent. I just wrote the wrong number down. It wasn't my calculator's fault. Yeah, it's 31.42. I know, I got it too. Okay, see what I did? I wrote the wrong thing down, so that means I'm going to throw away the video. It was 31.42. I just forgot to write the 1 down. But isn't that kind of interesting that, see how, yeah, it's the arc length, but you can verify it with just using tangent. So I don't care which way you guys do it when you see these problems, but I just look in the answer book and they say it's from this lesson, so that's why I knew that we had to do that way. Is there any questions? I have to delete this one. Darn.